Hello everyone, myself Sagar Ramesh Kute, working as Assistant Professor, Department of Physics, JMD College, Sinnar, Nasik. Now, last lecture we will discuss hyperfine structure. Now, in this lecture we will discuss NMR. NMR, the phenomena of nuclear magnetic resonance, that is NMR, first observed in 1946, deals with the transition between energy level that arises because of different orientation of magnetic moment of nuclei placed in the magnetic field. These transitions are studied by the means of resonance method. Hence the name of nuclear magnetic resonance. The techniques was applied to problem in the chemistry right from the discovery with the evidence of Fourier transform and avoidance techniques. It is become significant disciplines of its own. Now first, magnetic properties of nucleus. One of the most important property of nucleus, it is spin I and interactions spins angular moment h cross I. This gives rise the magnetic moment of the nucleus. The following rules are useful determining the value of nuclear spin I. First will be the if mass number A is odd and atomic number Z is even or odd. I is half integer. Example H11, C613, N715, F990. Second will be the if A and Z are both even, I is 0. Third will be the if A is even and Z is odd. The projection of the spin vector I of any direction can have values mi is equal to minus I bracket minus I plus 1 up to dash bracket minus I minus 2 comma I minus 1 comma I. These are 2I plus 1 in the number and all the detergent in the absence of external magnetic field. The magnetic field is split up into 2I plus 1 state. The magnetic moment mu associated with the spin angular momentum is given by mu is equal to gamma into I h cross. Hence gamma, where Gn is the nuclear G factor. Here gamma is the scalar called gyromagnetic ratio and may be take positive or negative value. An alternate expression for magnetic moment is mu is equal to Gn mu n into I, where Gn is the nuclear G factor is small dimensionless algebraic number that take different value of different nuclei. Mu n is the nuclear magneton and defined by the mu n is equal to E h cross upon 2 mp is equal to 0.051 into 10 raised to minus 20 here, where mp is the proton mass. Now this will be the magnetic properties of nucleus. Now second will be the resonance condition, where nucleus of magnetic moment mu is placed in the magnetic field B0. The interaction energy E is equal to minus mu into mu0 is equal to minus mu b0 cos theta is equal to minus mu b0 into mi upon I. Since mi can have 2I plus 1 values, will be have 2I plus 1 equally space energy level. The energy separation between any two adjacent level is given by delta E is equal to minus mu b0 into delta mi upon I is equal to mu b0 upon I is equal to Gn mu n into b0. The basic of NMR experiment is induced transition from lower level to the next higher level. If V is the frequency of electromagnetic radiation that induce transition between adjacent energy level, Bohr frequency condition is then H cross V is equal to mu B0 upon I is equal to G n mu n into B0. Now this equation is the resonance condition. For a spin 1 by 2 system, we'll have two states. The corresponding M1 is equal to half and the other for Mi is equal to minus 1 by 2. The energies are E 1 by 2 is equal to minus mu B0 and E minus 1 by 2 is equal to plus mu B0. The resonance condition is reduced to HV is equal to 2 mu B0. This figure indicates the energy level of spin 1 by 2 system in the external magnetic field B is equal to 0. These are represented from proton mu is equal to 2.79268 mu n and therefore V is equal to 2 into 2.79268 into bracket 5.051 into 10 raised to 27 minus 27 upon 6.626 into 10 raised to minus 34 B0 is equal to 42.5772 into 10 raised to 6. Typical external magnetic field used in NMR experiment are in the range 1 to 5 Tesla. Magnetic resonance parameter for some of the nuclei are listed. The frequency fall in the radio frequency region of the electromagnetic spectrum and the source used to induce the transition of different from those used other region of spectroscopy. The resonance condition is achieved by applying the radio frequency field oscillating at the laminar frequency perpendicular to external magnetic field. This oscillating field produced by applying oscillating voltage to coil whose axis is perpendicular to the external static field. Proton is one of the most important nuclei having spin I is equal to 1 by 2. It is constituted in the almost all organic molecule. The NMR proton nucleus is often called proton magnetic resonance, that is PMR. Another nucleus which present in all organic compound in carbon as C12 has no magnetic moment, it will not show NMR spectrum. However, 13C has the magnetic moment and shows resonance. NMR was first discovered in 1946 independently by the Puzzles, Pound and Trolley in the paraffin or blotch. Hence the package in water. It is intersecting to noted here the famous Dutch physicist C.J. Grouter 1942 was first person was look nuclear magnetic resonance in bulk matter. Due to his bad luck, he fails to observe the resonance as the sample was easily saturated because it is large spin lattice relaxation time. Now this will be the resonance condition. Now in this lecture we will discuss magnetic properties of nuclei and resonance condition. Thank you so much.